as we look at assignment 9 from chapter 6, we're going to look at question number 42 together, the question we had most often on this homework assignment. So assignment 9, number 42, starts us off with a situation where we have a quarterback. And he throws a football with an initial velocity of 64 feet per second. And we're using that same formula that we used a little earlier in this chapter. Remember when we looked at the person being shot out of the cannon for the circus? We're using this equation. And his goal is that he wants to throw a 40-yard pass. We want to see if that's going to happen. And they remind us in the problem that's 120 feet. Now we need that because we're working up here. Our initial velocity is in feet per second, so we have to make sure our units match, and they helped us out with that information. So I'm going to plug in this initial velocity into my problem, set this 120 feet in for r into the problem, and let's see what kind of information we can start to simplify. When I see this, before I go start turning to my calculator to help me out with that, I want to simplify this. And when I do 64 squared and divide it by 32, we get that same number we got in class together, 128. Now this is again where you have that choice where you're either graphing it in a y1 and a y2 and finding the intersection points. Or if you're like me, I like to move everything over to one side because then I know I'm at least just looking on the graph. That's an 8. I'm looking on the graph along the x-axis. I don't have to go hunting anywhere else. So I'm going to type all of this into my y1. Should I be in degree or radian mode? Doesn't really matter. They don't tell us which one. What are we more familiar with? Degrees. Let's put this stuff, I'm going to put mine into degree mode. So I'm checking my calculator. I'm in degree mode. Check, check, check. Good to go. And I need to, I prefer it this way, so I'm going to write mine like this, where I have it set equal to 0. When I have this, I'm going to search my graph for all the zeros of it. So zoom 7 always to start, and it looks like it's a pretty crazy looking graph. So my graph is looking pretty wild and crazy. I need to limit it in some way. And if you're thinking about what a football player may be keeping in mind, he's trying to get here to the end zone. Here's my little goalpost going on there. He's trying to get to the end zone, and this means he wants to throw his pass this direction. Now, if he throws it like in this direction, they usually call that spiking, and that's when you just want to stop the clock. If you spike the ball this way, I think they give you a penalty for that. I forget what that's called, but you're not. What's it called? A fumble? It's called a fumble when you spike it behind you. Intentional grounding, there you go. And if he were to throw a pass, listen up please. If he were to throw a pass this direction, the other team would have to pay his paycheck because he's helping them out. So we only want quadrant 1. We want to limit ourselves from 0 to 90. So I'm going to go set my window settings from 0 to 90. Ladies and gentlemen, stay with me, please. When I limit myself from 0 to 90, I need to do a nice little graph sketch. Anytime you're solving anything using your calculator, please sketch me a graph. It's just a nice thing to do so I can tell if you've entered things incorrectly. Here's what that graph is kind of looking like. It's actually going to continue going up and down because it's a sine wave. But I need to calculate these two zeros. If you are finding the two intersection points, you also need to set your Y maximum, somewhere up about 150. Bless you. Bless you. Next. Trevor, you next? There it is. So we need to find these zeros, and since he needs to throw a 40-yard pass, we have these two solutions going on here. So I'm going to calculate that first one. Finding the 0, set the left boundary. There's my cursor. That's looking pretty good for a left boundary and a right boundary. My first angle that I'm finding is 34.82 degrees. In the same manner, calculate that second angle, and these two angles that we're looking for are our two solutions. So you should find two angles. 34.82 degrees is one of them. And of course, if you're working in radians, there's certainly no problem with that. You would just calculate the same thing in radians.